Let's go ahead and do an example of graphing parabolas. The first example we're going to do is y equals 3x squared. So if you notice, there is no b term, there's no c term. The no c term tells us our vertex is going to be here in the middle, and no b term tells us that, like I said before, that our axis of symmetry will be that y-axis. If it had a b term, we could shift it to the left and shift it to the right, but not today. So step 1 says make a table of the values for y equals 3x squared. So once again, this is going to be symmetrical to the y-axis. So I'm going to have points to the left of the y-axis, and I'm going to have points to the right of the y-axis. Because of that, I will need to pick points that are to the left and to the right of my y-axis. In other words, I'll need to pick some negative x values, and I will also need to pick some positive x values. Pick x values that are easy, and pick x values that will be on the table. If I pick negative 15, is that a point on this parabola? Yes. But by the time I square it and multiply it by 3, it's not going to be on this graph. So as you become more familiar, make sure you're picking good, positive points. Not positive, good points that will fit on the graph. So I'm going to say easy. My first point is going to be negative 2. Well, if x equals negative 2, all I have to do to find that y value is to plug it back into my equation of y equals 3x squared. I'll do that up here. So I'm going to say y equals 3, what's my x? Negative 2 squared. So if I follow PEMDAS, it's the same as y equals 3 times 4, or y equals 12. So my y value will be 12. Pick another point on the negative side. I'm going to pick negative 1. Plug it in back for my x in my equation. So I'll be left with y equals 3 times negative 1 squared, which is the same as 3 times 1, which is the same as just 3. So I know the second point of my parabola, my quadratic function, will be at negative 1, positive 3. I'm going to plug 0 in. And if you'll notice, for all of these parabolas that don't have the b, since they are symmetrical to the y-axis, the vertex will always be found when x equals 0. And if I plug 0 in for x, well, x squared, 0 squared is 0. 0 times 3 is 0. So we know that this graph is going to be symmetrical along the y-axis and have a vertex of 0, 0. Pick one value higher, 1. You'll notice something here that's going to make our lives a lot easier. If I plug my 1 in for my x, I'll be left with y equals 3 times 1 squared, which is the same as 3 times 1, which is just 3. And you might be saying, hey, that's the same value I got for my negative 1. It will be. You'll notice that your negative x values and your positive x values will have the same exact y value because they are symmetrical. So we should be able to guess that 2 will be located on positive 12. Let's do the math just to make sure. If I plug 2 equals into y equals 3x squared, that's going to be the same as y equals 3 times 4, and 3 times 4 is 12. So we do get the 12 that we thought we'd have. So once again, if you notice, negative 2, 12, positive 2, 12. Negative 1, 3, positive 1, 3, and a vertex of 0, 0. Before I graph, if you guys notice, there's no negative sign here. None at all. That tells us this is going to be a positive quadratic or a positive parabola, which means we'll have our U shape. And if we went to talk about what type of vertex it has, it would have a minimum vertex because it has a minimum point. So if I graph my points, go to negative 2 on my x-axis, go up to positive 12, put a point there. Negative 1, positive 3, 0, 0 is going to be my vertex, 1, 3, and 2, 12. And hopefully you can see those dots make a parabola shape. So when we draw this, we want to make it very smooth and make it curve down here. So I'm going to kind of go just straight down, go through all my points and make a parabola, and you put arrows on the end, and you just learn how to graph your very first quadratic function, your very first parabola. If you need help, rewind it, look at the notes, and watch it again. Time to do step 2, or problem 2.